Hello coders, welcome to my video. In this video, we'll see how to use a constant with a pointer. Okay, as we already know, the constant keyword is being used to make a pointer or its value a constant, so that it cannot be modified, by mistakenly using that variable. So for that, we use constant keywords. So there are three flavors of constant keywords that we use with our pointer. So first is a constant keyword we'll use, and for example, I have an int pointer. This is p1. Okay, an integer variable as well. I have the value as 7, and I'm giving the address of value to it. So this is the first flavor of using a constant. So as a nomenclature, how we see this? Okay, we will read it from right to left. So this is a pointer to a constant int. What it means? So the value pointed out by this pointer remains to be constant. So what is a value? Value is 7. So this pointer is pointing to the variable having the value of 7. So we cannot modify this value 7 of this variable to this pointer. So what if I modify this value? So for example, I will take star p1. Okay, so this is the value. I make it 9, for example. And I'm trying to print it as well. So what it is, the value of P1 is equal to percentage T, and in that I will take star of P1. So let's see what will be the result. So if I compile it, so you see you will have an error. So this error state assignment of read only location star P1. So here the P1 star P1, the value that is constant. You cannot change it directly. So this helps in explicitly modifying the value of this pointer. So this is the first flavor we have. Okay. So let's take the second flavor. So the second flavor will be if we remove this constant from here and we make it after this. Okay. So how to read it first? So it is a constant pointer to integer. So integer is a value. Okay. So from this, you can understand you cannot change the address of this variable, but the value you can change. Okay. So how to check this? So first, the same I'll do star P1, I'll change the value because here we see we can change the value in this. So it would be, for example, 10. I save it. Okay. Then I'll print this value. So let's compile it. Okay. Compile is successful. Then we'll execute it and we get the value of P1 as 10. So there is no problem in changing the value of this. Okay. So what if I have one more integer over here? So I have int value 2 is equal to 11. Okay. And what I will do, I will point this pointer to this second value. So I'll take value 2. Then the same star p1. Okay. So when I save it and I compile it, I got a compiler warning error here. So what it says, assignment of read only variable p1. So p1 is equal to address. We cannot change this address because this is constant. So we should be very precise. This constant is before this star or after this star. Okay. So the third flavor. So this is the point, and the third flavor of using the constant is we can make the constant here as well. Okay, so how to read it so that it is easy to remember. So it's a constant pointer to the constant integer. So both are constant. We cannot change the address pointing by this pointer, also the value pointing to this pointer. So whatever I will do, it will give me a warning, an error. So if I take p1 is equal to 14, you see you get 10 error. And if I do p1 is equal to address of value 2, it will also give me an error. So in both the cases, we'll get a read-only error. So this way, we can protect our data as well as the pointer. Okay. So next case, what I will do, I'll take a function. Okay. And how this constant is used within the function, that we will see. Okay. So for example, I'll remove this as well. So what I will have a get message function, and there I have const integer star array, and here I'll take a void pointer. Okay, and what I will do for this, I'll take a loop int I is equal to 0, I less than uh take it 5. Okay, and I plus plus. And what I will do here, arr I is equal to I plus 1, this way. Okay, and here simple I return. So I have an array, for example, integer array, and I have 5 elements over there. So 1, 5, 7, 9, and 10. Okay, and I will pass this to get message. Okay, so this way, if I pass this array that is not constant, but once I pass to this function, this is passed to this constant parameter. So for example, let's take first this without constant. So there is no error. So if I compile it, okay, return this. So no error. Then when I compile, better I take from here the value of array percentage d is equal to percentage d, and here I have arr, then I have I and I comma I arr I, and in this I'll take this loop same, put it over this so that I can print each and every value. If I compile it again, so you will see you will get all the values 1, 2, 3, 4, 5. Okay, because once you send this array to this function, the values are from first is 0 and it's 1, 2, 3, 4, 5. So it got overwritten. So if I don't want this value of the array to be modified in any way, and I am passing this to this array, which is not a constant, to a constant pointer. So what happens? So we cannot modify the value of arri. Okay. So there, when I compile it, I'll get the same error. It's a read-only location. Okay. So let's take another scenario. Okay. So what I will do, I have a constant integer star ptr is equal to address of x, and integer x is equal to 20. Okay. So what is the solution? Like this is a constant value, and if I move this value to a non-constant thing, like I want to modify this x. So what will I do? So for that, I'll take a new pointer. I'll take a star ptr1, and I will typecast this pointer to integer start only. So like this, if I do, so you see your warnings is gone, and what I have to do, I will change this value. So if I change star ptr1 is equal to 61, then what is the value I'll print here? So ptr1 is equal to percentage d. Okay, so here we have ptr1 star. Let's see what is the value. I'll compile it again. You will see you will get the 61 value. Though this is saying we cannot modify, still we modified it. Okay. So what if this is a constant? Then it's again. So this is all about constant pointer. If you have an issue, just send me a message. Thanks for watching.